Okay, guys, apologies for that. Folks on the live stream, sorry about that too. We've trouble getting the audio in, so we're just gonna hope that the projector laptop picks up the ambient sound, and we'll make that work. But anyway, thank you all for being here. As always, thanks to our sponsors. We have Hashtel, LBMC, we have Frost Brown Todd, BTC Media, and then of course we work for the venue and the beer. I'm going to turn it over to Corey. I'm excited to hear this presentation. I think that a lot of the blockchain world is bumping up against these problems, but haven't spent enough time with them to either be able to articulate them or know the problems that they're hitting. So I don't think anyone spent more time with it than Corey. So I'm going to hand it over.
Thank you, John. All that really means is about hiring. I have 3 people in the kind of shadowy figure here. I have to remember not to walk around. So, good evening, everyone. I'm Corey Todaro. I haven't been up here over a year now. I've been hard at work upstairs for Hashtel. I'm the CTO of Hashtel. If you don't know Hashtel, we're a local blockchain company that's been around for about 3 years now. We work primarily with healthcare industry, and enterprise blockchain and distributed ledger technology. If you don't know what enterprise blockchain is, that's what we're going to talk about exclusively today. There is no crypto in my talk at all. And so let's sort of get things head on. The title of tonight's talk is Ledger Wars, which is somewhat provocative, and I hope it brought you here. But what we're really talking about is the explosive proliferation of distributed ledger software, services, and offerings for use by various enterprises in various industries to implement solutions utilizing blockchain-type architectures or distributed ledger technology. There are more logos in this presentation than I've ever used before, and there will probably be companies and protocols that you've never heard of. They're just all over the place now, and so it's really becoming a competition between a lot of different protocols and services and how can enterprises choose. But there are some seismic shifts taking place in the enterprise blockchain market that I think point in a very interesting direction that you don't see on the open source crypto side of the world at all, that will have very distinct impact on the ability and the desire for enterprises to come to this technology and to start articulating solutions and building and getting to work around that. And so, provocative title, but the real topic is the commodification of blockchain and DLT software and services that have exploded across the market, and how that fundamentally impacts adoption. Let's see if I have this here. The red button. Giles. Technical problem. USB key would help. Here we go. Yeah, I'll just walk over and tap it. It worked? Oh, you saw the laser. Well, that's only part of half the battle, you know. All right. So for many people, and I still hear it today, I've been hearing it for 3.5 years now, why on earth would we want blockchain used in the enterprise when the entire spirit of blockchain, going back to its mythological founder, is about decentralization and freedom and the ability to do the things that we want. And for many people, the notion of enterprise blockchain is literally heresy. I've written about this recently, and I know what I speak. I'm a religious historian by education and training. There are very deep theological debates going on about blockchain that have almost nothing to do with the interests of enterprise and business in the use of this technology. And so why would enterprise want to use blockchain? And their use can almost change the nature of the technology itself. It's about the distribution of complex business workflows, whether it's financial services, whether it's healthcare, insurance business, logistics companies, etc., and on and on and on. There are multi-party workflows which are very difficult and inefficient to process, which has a very distinct impact on the bottom lines of these companies. Tremendous amount of effort and treasure is being spent simply keeping records synchronized between parties. And so it's fundamentally a reconciliation problem. If you know anything about blockchain, the automatic synchronization of distributed databases, of the distributed record of actions that parties take, is the core value that we can bring to blockchain. Of course, in its original form in Bitcoin, that wasn't much use because no one can change the rules of Bitcoin. It has one set of rules about the utilization and the spending of a cryptocurrency. But it's about efficient synchronization and the ability to compose workflows for enterprise through the use of what's probably called smart contracts on these blockchains. We can compose these workflows, we can build business rules that match the workflows that we're engaged in and achieve higher levels of synchronization to avoid costly reconciliation, things like chargeback, clawback, great phrase, very common business. I paid you, but I think it was a mistake. I'd like some of that money back now, right? Crazy kinds of workflows that take place. But ultimately, if we can bring a new transactional infrastructure to many different business verticals, it's about new value creation. It's about achieving new ways of doing business that aren't possible today with either our siloed database structures and or our communication standards that we use to send data back and forth. One of the problems, I think, across businesses is that we often have standard communication protocols, EDI forms, or standards. So an EDI form is simply saying, okay, if you're going to communicate about this business process, here's how you need to structure that communication. And then we beam that message off to the other party. What they do with it, though, is completely out of your vision. Whether they are using it correctly, whether they're applying the rules correctly, all you know is that you successfully put together a sentence with the right grammar. But you don't know if your counterparty understood it, or understood it well enough to communicate back to you something that you agree with. And so often we'll send out messages and we get something back from our counterparty, and it makes no sense whatsoever. They're referring to a state of the process that doesn't match my own view of the world. And so the opportunity for blockchain is to open up those black boxes and not only have a standard form of communication, but a standard form of transparent processing of those business processes so that we can achieve more value. But what we're not going to talk about today is basically, which is an enterprise, which is a blockchain, but not today.
You ready for the next slide?
Yeah, and you might think I'm crazy to talk about enterprise blockchain the week that crypto explodes and Facebook rocks the world around cryptocurrency, but I'm not going to talk about that. So past this prologue, how did enterprises come to blockchain? And we have to go all the way back to 2013, 2014 to really get at the origins of it. And it's really two primary factors that we need to look at. And the first is the development and the emergence of the Ethereum blockchain, which is a cryptocurrency, but one with a very important characteristic. Ethereum was the very first blockchain that allowed us to compose smart contracts. Right? The very inspiration of it is the frustration around the creators of Ethereum working in Bitcoin and saying, I'm really tired of trying to make this blockchain do different things. Colored coins, smart contracts. It wasn't built to do those things. And so rather than trying to shoehorn in new functions and features atop Bitcoin, let's just start from scratch and build a composable blockchain that allows the developer and the community to write business rules that govern transactions on the ledger. And so the ability to compose smart contracts really opened the door to say, I can not only build contracts about the movement of crypto, but I can build contracts that can model various numbers of business processes. The second important function is about permission blockchains. Permission blockchains used to be the hot phrase back in 2015, 2016. The very first one of permission blockchains was actually a very small company headquartered in China called Hyper. And actually their instance was called Hyperledger. They were building the world's first permissioned blockchain using a PBFT, that's Byzantine fault-tolerant consensus mechanism. And their goal was to build an enterprise blockchain. Another small company out in the world called Bits of Proof out of Germany also had a protocol model. Both of those companies, Hyperledger and Bits of Proof, were swept up into what became digital assets in New York. We turned around and donated the name Hyperledger and a code base to the Linux Foundation. We said, we're convening a new organization, a new project to study and to build enterprise-grade blockchain protocols and applications. And so through that donation of the name and an original code base, Hyperledger project was born. Hopefully, I've all heard of Hyperledger out of the Linux Foundation. It now hosts multiple blockchain protocols, all of which are open source and which are designed for business use primarily. So we don't have tokens, but we do have composable smart contracts, and we have the ability to permission the network. So unlike public blockchains where anyone in the world can choose to run a node, all we have to do is download the software and connect to the network. And I too can be a miner, although I'm not going to make any money doing it, but if I want to, I can. And anyone in the world can see the transactions on every public blockchain. But the notion that we can make the network permissioned and say, I can know who those other nodes are. Are they my business counterparties? Company A, company B, company C, etc. In addition, can I hide what's on the ledger from people outside our business context? That is the origin of enterprise blockchain, because I don't want the world to see my business transactions. I don't want them to know the pricing terms I've negotiated with my counterparty. That's confidential, proprietary business information that's fundamentally unsuited to public, transparent blockchains. And so about 4 or 5 years ago, this movement kicked off with a couple of different protocols, permissioning Ethereum, permissioning the nascent Hyperledger protocols, and where have we gotten with that? So the real explosive youth of enterprise blockchain comes with the software course, in which we have an explosion of protocols that have become available. And a protocol is simply a software set that we can utilize to build a distributed ledger network to run applications. We have a whole family of Ethereum-related enterprise protocols. We've got Quorum, which is JP Morgan's version of Ethereum, essentially, with some important differences and changes. One of the co-founders of Ethereum, Gavin Wood, started his own company called Perry, which just this year has released something called Substrate, which is a composable Ethereum-style protocol ledger. We've got BlockX, a company spun out of Consensus, which has built something called Strato, again, inspired and significantly built upon the Ethereum code base. And we can see new styles of organizations, Consensus, Joseph Lubin's organization, who's dedicated to expanding the Ethereum ecosystem, as well as, unfortunately my logos are overlapping here, the Enterprise Ethereum Alliance, who's a standards body dedicated to specifying and developing specifications for enterprise-grade versions of Ethereum. So this is not your open Ethereum, these are permissioned Ethereum networks, fundamentally. But Ethereum is not the only game in town, of course. You have the explosion on the Hyperledger side as well, primarily with what's most well known as Hyperledger Fabric. Primary code contributor to that open source project is IBM. Fabric is a global permissioned ledger system with the ability to write smart contracts in a variety of different general purpose programming languages, Golang, C++, Node.js, Java, etc. They think it's best suited for the enterprise. Also, importantly, Hyperledger Sawtooth, whose main code contributor is Intel. Very well suited for supply chain types of use cases with some very interesting features around the concurrency of transaction models. But of course, there are others as well. That little triangle logo up top there is something called Tendermint, which plays in the crypto world as well as in the enterprise blockchain space. The really interesting architecture called application blockchain interface, API. And the C in the bottom there is Corda, which has been developed by a banking consortium called R3. Really interesting ledger model in that there is no global ledger in Corda. You don't share the ledger. All transactions are peer-to-peer between counterparties. And if you're not a party to the transaction, your node sees nothing, holds nothing, retains nothing about that transaction. You don't even know it's happening. It's not even that it's encrypted, you just don't see it fundamentally. So it's a very different paradigm that's built upon, although it is inspired ultimately by the cryptocurrency chain, specifically Bitcoin. There are innumerable others that I do not have space to put up here. Things like Hyperledger Aroha, Hyperledger Indeed, etc. But we have a diversity of ledger architectures, approaches to writing applications or smart contracts. I generally don't prefer the term smart contract. It creates magical thinking. Oh, just write a smart contract. Well, what does that look like? It's really just application code that we write and operates on the ledger. Smart contracting languages, as well as what we call consensus protocols. So mining in cryptocurrency is a consensus protocol. It's a method by which we know which node has the canonical version of the ledger and the next block of transactions that are connected to it. And so we need mechanisms in distributed databases to figure out how all the replicas, all the copies of the database come into agreement with each other. And with enterprise blockchain, we've had an explosion of different consensus protocols because we don't want mining. Mining is expensive, it's costly, it's suitable for open and transparent networks, but for business networks, we need something that is radically faster, and we need something that is radically cheaper than running hashing contests between clusters of computers, which is what cryptocurrency primarily does. And so we can achieve with some of these protocols transactional throughput at the scale suitable for financial and other kinds of business industries. We can see transactional volumes on the order of 10 to 20,000 transactions per second, whereas the average transaction per second throughput of Ethereum is about 3 to 12 transactions per second. Again, very different environments. One is open and transparent, and so we need very weighty consensus protocols to make sure nobody's cheating. In a business environment, we've got the legal system if you cheat. Right? I'm going to know that you cheat, and I've got lots of resources to make that right. And so we can use lighter weight protocols that allow us to achieve speed of business, unlike the open ones. And so this has been going on since about 2015, this explosion. And so enterprises who are choosing to experiment and to work on blockchain solutions have a wide variety of choices at their disposal. And their criteria for choosing is all over the map. Some enterprises might say, hey, I like the safety of IBM. Something like that old adage about IBM, no one got fired for choosing IBM. Right? So I don't know anything about this space. I'm going to go with something that makes my bosses comfortable. Right? Other people say, hey, I don't want to feel trapped. I'm going to go with something like an Ethereum type protocol because at least I can carry my application code to other versions of Ethereum. Some people are actually philosophical about it and say, I really believe in the vision of some of these protocol families. And I believe this is the future. And so enterprises are now faced with lots of choices and lots of different decision criteria that expand not only to the characteristics of the protocols, but even beyond them. And so as we move from the youthful stage of enterprise blockchain, we now come to a level of maturity, and I call it as you like it. Of course, as business is looking at new technology, who's coming to play but the large cloud providers and a whole host of other people. And so we get the rise of as-a-service offerings for blockchain and blockchain protocols. And so the cloud providers, AWS and Microsoft Azure, and IBM Cloud, of course, and Google Cloud, are now offering Ethereum as a service, Fabric as a service. And these are really just provisions, managed services for you to efficiently spin up nodes in containers or other types of orchestration arrangements, so you can quickly deploy test networks or other types of networks. There's lots of application development tooling that's also being brought to bear on the market, as well as the rise of consulting and design services, not least of which HashHealth does with healthcare companies. But the likes of Deloitte, Accenture, of course, EY, Cognizant are playing with enterprises, working with them on developing application and really learning what works, what doesn't work, what can we do with this protocol versus that protocol. There's lots of benchmark testing going on, but these as-a-services offerings are really becoming to dominate the market. And in fact, VMware has announced this year that they're launching their own blockchain protocol, unique to them, which will be a completely managed service on their cloud. All in terms of node infrastructure, storage, compute costs, and network for one price for a year. It's a really compelling packaged offering that speaks to the enterprise. The enterprise is like any other kind of user. They're your early adopters, your people who like to tinker. But as we reach the main part of that bell curve of Enterprises want something called a full product. Right? They don't want a protocol or a software development kit. They want tooling. They want DevOps support. They want support. They want high availability architecture, fallback and disaster recovery. They need these kinds of services in order to dedicate business to this new technology. And it is still very new technology for the enterprise to trust and commit to. And so the rise of these kinds of services dramatically lower the barriers to experimentation and to entry into the market of real production level blockchain and distributed ledger technological solutions. And so we have as a service, we have consulting and design services, we have management and orchestration tooling. BTP over there in the corner there is a really good example. They have a product called Sextant, which allows you to orchestrate Kubernetes clusters of blockchain nodes. And so you can orchestrate a network with a single interface on multiple different cloud providers at once. It's that kind of tooling that the enterprise is going to need if they're going to actually rely on this infrastructure for their daily business and their daily kinds of business drivers. And so this is what you've seen over the last year or so, these very big players coming into the space. It's not so much about which protocol is going to win. It's about which protocol is best for our business case and what kinds of service options are available with this protocol versus that protocol. And so we move way beyond the philosophical and ideological fights between cryptocurrency protocols. Am I a Bitcoin maximalist or am I an Ethereum idealist? We're really talking about practical applications here and the range of services that can be brought to bear. But this is not the end of the story. We lost our slide here. Come back in just a second. Okay, so beyond even this is the cutting edge developments that have taken place just in the last month. And that's the wheel is coming full circle with some very surprising new patterns that we're seeing in enterprise blockchain and DLT architecture. And the primary example I want to talk about is something called DAML. DAML stands for Digital Asset Modeling Language. It is a smart contracting language developed by a company called Digital Asset, who you actually saw at the beginning of the story in the collection of Hyperledger and the donation of that name and that code base to the Linux Foundation. They've developed a smart programming language. It's not a protocol. I can't go spin up nodes in DAML. Rather, it's a better language for writing smart contracts. It is more reliable. It's built on functional programming in Haskell, so it has very few side effects if you're a scientist. It's also human readable by a subject matter expert. And it's a domain-specific language for business relationships. It models counterparties, rights, and obligations, and how those rights and obligations evolve as we interact with each other atop a DLT or blockchain protocol. And most impressively, they've open sourced the language and have achieved integration partners to make DAML, the language, work on a variety of different blockchain protocols. So they've announced just in the last month integrations with Hyperledger Sawtooth and VMware's new forthcoming blockchain protocols called Concord. They announced just last week Hyperledger Fabric, R3 Corda, and a very surprising one, Amazon Aurora. Anybody heard of Amazon Aurora? Amazon Aurora is a cloud data version of SQL. It is a database. It is not a DLT. It's not even a blockchain. It's a SQL database. And so we now see the return to the origins of blockchain, which are simply relational databases or NoSQL, depending on your flavor. But we now have the ability to write smart contracts for single databases and not networks of distributed databases in the form of blockchains. Now, why is that important? Well, for the enterprise who wants to experiment with blockchain, their first step in the past had been we need to pick a protocol, which is a really poor way to begin a design process. I need to lock myself into a certain style of smart contracts, a certain style of network architecture. Is it a global ledger or is it not a global ledger? What kind of privacy features are on it or not? I've got to make these choices first before I can do any kind of application design work. This flips the paradigm on its head and allows enterprises to build the application first in DAML. Let us model the business process, run it through testnet, and see how it works. Then I think about who are my counterparties, can I bring them to the table? Maybe I can be the operator of the entire solution for my counterparties. We choose the network second. And so I don't have lock-in anymore. I've now got the ability to carry my application logic to a wide variety of different offerings, whether they're full service offerings like VMware, or some of the traditional global blockchain ledgers like Hyperledger Sawtooth or Hyperledger Fabric, or even the peer-to-peer model of an R3 Corda, or something like an Amazon Aurora, which is the first of a number of different databases that not only DAML will work with, which will be on the market. There's coming down the pike now 2 very interesting new database offerings, one from AWS and the other from Google Cloud. AWS has something called QLDB, Quantum Ledger Database. It is a single database which has cryptographic provability that what gets written to it and all future changes to it are legitimate. So you can track and prove that the database either has been untouched or that additions to it are per contract language that you've written to work on top of it. Google has a similar cryptographic database they're calling Trillion. They've got a very good white paper on it right now that you can read, actually uses Merkle trees, one of the core cryptographic primitives of blockchains. And so we see the return of the database, a single database instead of a distributed network. And so the other reason this is important is as we think about building enterprise solutions utilizing this range of technologies now, we can now begin to bring cost and rationality back into the equation. Then I know how much it takes to run a distributed node network on a per party basis. I mean, we can make those kind of calculations for Bitcoin, but we get that question all the time with our enterprise customers. This sounds like a really good application. I need 15 of my counterparties on it. How much we each have to put in a year to make this thing work? Is my IT department going to have to run that node? They've never seen a node in their life. They really don't know what this thing works like. Can you run it for me? And that's a really interesting option. It sounds exciting. Yeah, we can run all the nodes. Except then you realize if I'm running all the nodes, then what the heck are we doing with the blockchain? Because you're just trusting me at the end of the day. So why don't I just choose the platform with the best margin for my operating costs? And that might be a database at the end of the day. It may not be a fully distributed ledger. It may not even be a blockchain. And so we now have the ability to choose across a trust spectrum, across a services spectrum, and across a cost and margin spectrum for the best technology to bring to bear for these kinds of new multi-party workflow solutions that blockchain has originated. And so we really have come full circle. And so the notion of ledger wars is really about competition. Competition over cost, competition over network architecture, competition over portability of application code. It's really been a very quick evolution for blockchain. I think fitting where we are today with our network society and our wide availability of cloud architecture and cloud infrastructure that we can bring to bear. It's kind of like the evolution of the internet, but in fast forward. It's only taken about 5 years to reach this level of diversity and this level of completeness in terms of a full product offering for enterprise to employ for blockchain and DLT. So if we're going to use the war metaphor, then go bid the soldiers to shoot. Because it is on now. It is on with the likes of Amazon, Google, Microsoft, etc. It is on with a wide variety of companies who are developing new cryptographic techniques for distributed databases, and it is on for application developers to find the best and most reliable and most flexible tooling to bring this kind of new solution architecture to the variety of businesses across the globe. So, thank you very much. I think there's one more button here that I'm not going to talk about Facebook. So we have some time for questions. Right. So the question is between a smart contract language like a DAML and a basic, well, I mean, it's a serverless SQL database. So is cloud native. What's the connection point there? What's the integration point there? And yes, so the smart contract operates at the client level, where different clients can be provisioned to different counterparties. And the YAML code or the smart contract code dictates what they're able to write to that database or to change about that database. And so in YAML terminology, if I have the right to make an update to that ledger or to take the next step in the business process, then my client would enable me to make that change to the database and to write to it. If I don't have the right per the smart contract, I simply can't write to the database in that regard. The cryptographic underpinnings of the database, this is not an Aurora, this would be like in a QLDB or in a Trillion, I could then turn around as the operator of the database and provide proof to those client users that it's not just me making those decisions on your behalf, it's actually the code and it's actually cryptographically enforced on the database, that it's impossible to make those kinds of changes to the database without the authorization of the application code. And so it is a single database and you are trusting the operator of the database, but it gives you additional guarantees that the operator of the database can't rewrite it at will, fundamentally, against all service level agreements and otherwise.
So in the case of QLDB, QLDB was doing that kind of transparency.
Yeah, absolutely. In the case of a regular SQL database like Aurora, it is about the trust of the operator, it's about the service level agreement and the rationality of all the players. But we still have the ability to write multi-party workflows in a very programmatic way. So all the parties understand exactly what's possible and what's impossible given the current state. And one of the benefits of blockchains in general, but specifically with smart contracts, is that all the counterparties share the real-time state of the business process. I can't overstate how valuable that is because we're always operating in the dark as businesses. In healthcare specifically, there's a realm of new contract and payment styles called value-based contracts. I worked for a large hospital company. We operated for a year without really knowing how we were performing because the KPIs were not measured by us, they were measured by Medicare. And so we had our own internal calculations, right? And we were making good bets, if you will, but we really didn't know, and we wouldn't know for 18 months. And so a lot of these arrangements are, I want you to take financial risk now, and I want you to perform in a vacuum of information. And if you do well, you get bonused, and if you don't, you get penalized, but you're not going to learn your fate for 18 months. Now go, right? It sounds insane, but businesses are doing across all kinds of industries. And so for the ability for counterparties to share, I know exactly where we are in this business process. I know what's next, I know who has to do it, and when it's done. It is incredibly empowering in the reduction of cost and the ability for us to do new value creation, new styles of businesses that simply aren't possible because we don't have the infrastructure for it. And so cost efficiency is kind of the first hurdle that we get to with DLT and blockchain and enterprise. But beyond that, I think there's a really rich area of exploration. We've got better, more responsive infrastructure for our businesses so we can do fundamentally new kinds of things with each other. Yes?
For your healthcare example, how does this help us when we're so reliant on the slowest player in the space, the government, and CMS is directing like Gypsy?
Yeah.
And we're all stuck wondering what the next going to happen in 18 months, but the government ultimately is the controller of the rules of the road and your performance as it relates to their incentive payments. Right. So that's one. So I think that really stymies healthcare because the interaction, deep interaction with the government and all forms of fashions of what we're trying to accomplish and take care of patients and do it in so efficient manner and effective manner.
Sure.
Secondary piece is, I was questioning myself, for your enterprise clients, you have to come in and select it kind of an operational basis from the get-go. Now they have this other backside way to do it with more selection. Is their vested interest or their vested payments in setting that up wasted? And what is their action going to be when they see new flexibility demo and what's presented as far as what's here now this month? Because that would be extremely frustrating if I had just spent a ton of money
Sure.
set up a very specific set of programming.
Right. Well, two great sets of questions. The first of which is a healthcare example, but the fundamental question is the intention of your counterparty or your ability for your counterparty to move faster than they can today. And this is the interesting overlap in all DLT kind of design. Some of it is technical, and some of it is what I'll call political, or the intentions of your counterparties and the abilities of your counterparties, what I would call network concerns. And technology can't solve for malintent. Right? If I don't want to pay you on time, I'm not going to pay you on time, no matter what the technology enables. Or if I'm not able to pay you on time, it's just not going to happen faster if I can. And so in some cases, we can't solve it. And healthcare is a particularly thorny area because unlike some other industries, it is what I'll call a morass of misaligned incentives. Everybody's got their own incentive and they usually don't align with yours. And I've likened it to a knife fight in a dark closet. There's a lot of people with sharp edges and they're stabbing at each other. You got the payer, you got the pharmaceutical manufacturer, you got the provider organization at the hospital level, at the clinic level, at the network level. Everybody wants something different. And in the middle is the patient who's kind of lost, wandering around, wondering, how much does this cost? What's going to happen to me? I don't know. And so that's an extreme example. But here's what blockchain can do, even if people don't want to pay faster. This is a great example I have to attribute to a colleague of mine in New York. He said, well, you know what? I mean, then we were talking about claims. Whether or not the insurance company wants to pay faster. They pay on average 30 to 45 days to a doctor. And they make good money off of that 30-day wait, right? So there's a nice float there. And so you would think, well, they're going to have to want to pay faster if you utilize the blockchain. Maybe not. Maybe the value is not in getting paid faster, but in knowing the true value of the claim faster. Right? If I'm a doctor, that claim is a moving target until it gets paid. It could be 100%, it could be 85% of what I asked for, it could be unlikely, it could be 120%, but who knows. And I can say to the insurance company, keep your float, right? That's valuable to you, that's fine, but tell me on day one how much I'm going to be getting. And then I can do a variety of other things with that information. I can securitize it, I can use it as collateral in a variety of business situations. And so even if we can't move incentives into perfect alignment, there's a lot of room for getting creative on how we design DLT and interactions between counterparties. Your second question is, what's the reaction when we learn that sometimes our work is experimental at best and may not lead to further development? And I'll just speak from my own experience. A lot of our clients were burned by the AI wave, which has preceded blockchain. Gone off and set up labs and centers of excellence for AI and machine learning development, maybe thrown a couple $1 million at it, and it went nowhere. And so we find generally, maybe it's specific to healthcare, I'm not sure, I don't work in other industries, is that enterprises are extraordinarily cautious when it comes to technical innovation. They're not going to go off and do two things. They're not going to spend a ton of money on trying to build the solution first. At least our clients want to learn first. They want to experiment. They want to fail. They want to learn, where's this thing break and what can I rely on it to do or not. And I want to experiment and fail cheaply. And I want to fail and experiment quickly. And so in some contexts, it's okay that we build on a prototype that is not going to go all the way. There was a great article, I'll find the link and we'll share it over Meetup. Someone's estimating that the initial blockchain applications in enterprise have a shelf life of 2 years before they'll have to be fundamentally redesigned on new architecture. Right? That's a pretty quick life cycle for any kind of software development. And so I think that's already being baked into some of the attitudes. But something like a DAML, I don't think it's going to be the only protocol agnostic smart contracting language fundamentally changes that dynamic. And so it really is, I'm investing in something that I can carry forward, and I can now separate application development from some of this back-end infrastructure evolution, and really wait, in some cases, for the best offering available to me to deploy this. The second way that enterprises really hedge their bets, at least in healthcare, I know this is true, is no one or very few enterprises in the world are going to their core architecture, their core pieces of technical infrastructure and say, I'm going to rip and replace that thing with blockchain and DLT. That is a huge bet. And so we find that people are willing to experiment around the edges or the adjacencies of their business before they're willing to go into the core and really rip out a piece of very well-tested and battle-hardened infrastructure. Right? I know that insurance companies are still running mainframes, and And let me tell you, they have optimized those things beyond belief to have life cycles of 40 years, right? That is investment that they are very unwilling to part with based upon the promises of a flashy new architecture. There are some really good examples, though, of enterprises are going to the heart. So two of them primarily are in equities markets. The Australian Stock Exchange and now the Hong Kong Stock Exchange. Australia is the 9th largest in the world, who's replacing their core settlement engine with a new DLT build. Now, it's not an open blockchain, kind of network. It is an operator model. The ASX is an operator for financial services in that market, and they're building a better engine to better service their clients fundamentally. So it's not a philosophical choice. It really is a pragmatic choice, but it is a large one, and that's a project that's going to take 4 years. That's on the order of civil engineering, if you will, from a technical perspective of how big and complex that build is. But they've made that commitment, and they've got a turn-on date, and we'll see when they have a turn-off date from the old infrastructure. But that's going to be a really, really compelling thing to watch. And I've commented on in the past that it's one of the most real blockchain applications that I've seen in enterprise. There's a lot of announcements about experiments, and that's fine. We do that work. Our competitors do that work. Enterprises do it all over the place. But that's one of the real examples of someone standing up and saying, we are making this bet and we're going forward on it. So I think we're going to see more and more of that as enterprises and IT departments, frankly, get more comfortable with this new style of architecture and the various tooling that we can bring to bear on it. Yeah, another question?
Yeah, follow up with, because I'm just curious, frankly. With the payer contract you did, we talked about the 30 or 45 days of pay. How can you make it a smart contract? I know there's players involved. How can you make, a lot of time in that period, there's either medical necessity issue, can't analyze by a person or negotiate by a person in person. So you can't necessarily set a rule for it. You can set a rule in the contract and your general custody negotiated. But there's different opinions on that sort of thing.
Sure.
Or if you're trying to see if your admitting patient moves the next step, utilization review.
Right.
What is that about? That's an interaction person-to-person
Sure.
discussion.
How much of that interpersonal reaction is actually waiting on data to be available to have the interaction? So, I mean, I think if we look at very complex and lengthy business processes, how much dead time is in there just to make the data available here or there? What we're really talking about with enterprise blockchain is integration of these ledger systems in with production level data systems. To say, hey, look, we know what the minimal data set is to reach this determination, and we're going to pull that data as fast as possible onto this common shared record and let the logic handle it. And if we disagree, maybe we can halt it. But at least we both share where the data came from, what it says, and the rule that was applied to reach the determination. And let's just get that out of the way as fast as possible. If we have an honest disagreement about something, let's have the honest disagreement. But let's not sit around and wait for, oh, did you send the data? Yes, we did. We have to look at it. Well, we have to normalize it or transform it in some way. I mean, there's a lot of dead time and really wasted action in some of these lengthy business processes. And those are the ones I think we can speed up fundamentally. But if there's, I mean, technology, of course, can't solve some things. The data is not available, or it's not available from this party. It's a third party request. How can we get them to give it to us faster? And so some of these application designs, and that's why blockchain is really a mix of technical engineering as well as kind of sociology. You have to understand what the counterparties want, what's important to them, what they're capable of doing, to really design a really good solution that can bring value to all those parties. So it's not really one-sided in that way. But these are all great questions that reveal just how hard some of this work can be. And in some cases, it's impossible. You can't solve that problem.
Can you comment quickly on, one of the enterprise core demands is privacy? Can you comment on how privacy is handled across kind of these different protocols? Some of the
Sure, I can back up a little bit. Privacy is an obsession of mine. If I were to write a PhD thesis in my job now, it would be about privacy on blockchain. I've spent just a stupid amount of time thinking about it, but it's what always has troubled me about blockchain and DLT. If you can get it to go back a couple slides, the salt of youth one. There we go. So the original blockchains are radically transparent. Everyone can see everything that happens on the blockchain. I can see every Bitcoin transaction that's ever happened in the past 10 years. Now, there's a privacy model of a sort on Bitcoin. It's the pseudonymous wallet address, right? It's not my name attached to a Bitcoin transaction, it's a wallet address. And I can generate those at will. And so it can be hard to attach a wallet address to an entity or an individual, but it is certainly not impossible. And governments are very good at this now, tracking money laundering, organized crime, terrorist funding, etc. When you can start to correlate external events with a blockchain transaction, you can start to look behind the wallet address and figure out who's really doing these kinds of transactions. And so it's not really privacy at all. It's what we call pseudonymity. It's not anonymity at all, because all the records are there, and they will always be there. So all you're doing is giving a lot of information for those algorithms to run and try to figure out who's doing what. And so when enterprise blockchain got started, the notion of how are we going to handle privacy is a crucial one. Not only from a business attitude perspective, well, I don't want to share this data, but regulatory concerns are overarching. I can't share this data. I can't make it available to anybody who cares to look. And so the very first effort at doing privacy is around network architecture. We'll make it permissioned. And so instead of a radically transparent ledger that's visible to anybody who cares to look and open for anybody to run a node on, we're going to restrict that and say, you know what, in my network, you have to be one of my business counterparties to run a node. And we'll, in fact, restrict access to who can see the ledger to this group of people here. And that begins to make sense until you think about, well, what kind of business are we going to do on this blockchain? I can do data sharing. I can transact data that is fundamentally not valuable to me. It might be valuable to you, but it has to be data that I don't care who sees it in this network. And so the set of business problems which that applies to is actually extremely small. What kind of business process do I have where I don't care what my competitors see about me and what I'm doing with other parties in the ecosystem, right? And so that gets you only so far, but it really limits the kinds of applications you can write. And so now we have an explosion of new kinds of privacy mechanisms that come to bear in these different protocols. They all have their pros and cons. I'll talk about three very basically. The first is with Hyperledger Fabric. They began something called private channels. So yeah, we have a global ledger that we share on a permission basis between all these counterparties. But if I want, I can transact one-on-one with another counterparty, which sounds cool. But you dig down into the architecture and you realize two things. First of all, that private channel is actually another ledger, but it's a ledger with two parties. And if you do math, you begin to realize the nightmare that this architecture becomes. To have private channels for all the constituents on a network, right, is what is it, 2 to the n minus 1, which grows very big, very fast. And in fact, SWIFT, the banking consortium, or the banking communication layer, did a trial on Fabric private channels, and they estimated that at scale, for their proof of concept, they would need 358 private channels. But at scale, you would need perhaps tens of thousands of private channels, which means that your node is running 7, 8, 10, 20 different ledgers at once. And it gets very clumsy. The second downfall of the private channel approach is that assets that you transact across a private channel are not interoperable with other ledgers. So I can transact one-on-one with my counterparty, but I can't take the example of that asset to another private channel and transact it with party C. So you're stranding assets and you're stranding business workflows within these private channels. And so it becomes a development operations, a DevOps nightmare, while you're also reducing some of the utility that you have in the ability to interact with a wide variety of players. And so it's an interesting approach, but ultimately I think it's one that becomes overcomplicated too fast. And none of these are at production scale yet, so these are estimates on what it would take. But it's certainly a warning. Oh my God, that looks pretty scary. The second approach is something like a Corda. Corda went with a radically different ledger architecture and said, forget the global ledger. There is no global ledger. Your node has a ledger which is yours, and it's a record of what you do. And it's a record of what you do with any other counterpart. And all transactions are only point to point. Now, the big difference there is you get, with a global ledger, you get cryptographic guarantees on these blocks of transactions, blockchain. Blocks are cryptographically linked to each other, and they have Merkle trees inside, and so if any one transaction changes, you can immediately detect it going on and up. So you get these cryptographic guarantees at the ledger level. With Corda, you get cryptographic guarantees at the transaction level. There are no blocks of transactions. There's no blockchain. In fact, Corda and R3 was the first people to develop the phrase distributed ledger technology, because people said that that's not a blockchain. What they really meant was, hey, you dirty enterprises and banks, don't play with my new ideological tool. And they said, you're right, it's not a blockchain. Both ideologically and technically, it's not a blockchain at all. And so this model is very interesting in that you get privacy guarantees at the transaction level, but I also get portability of the asset between counterparties. Two flaws, or two, what I'll call drawbacks of this model, and there are always costs and benefits to every model. One, it's node heavy. To transact on the Corda network, you've got to be a node operator. I can't provision access to the ledger to a client. Every transaction entity is a node with a certificate attached to it, an IP address, etc. And so that means that every counterparty has to run a node on the network, which could get expensive and or costly or complicated from a DevOps perspective. The second problem is, although I can transact party to party and no one else sees anything, if someone takes that asset and transacts it with a third party, they're going to know it came from me originally. And so I can't hide the history of an individual transaction if it goes to a third party or a fourth party or a fifth party. And so there is some information leakage in that model that comes to bear. In many business contexts, I don't want that to happen. The party shouldn't know where that asset came from. They should just know that it was legitimately my counterparties, and now it's legitimately mine. The title history of some assets shouldn't be open fundamentally to counterparties across the network there. And so that's another interesting approach. There's a third approach, and that's one that's talked a lot about in the blockchain press, and that's the zero knowledge proof. How many people have heard of zero knowledge proofs? Zero knowledge proofs are these really bleeding edge mathematical and computer science formulas. It is essentially possible to prove something is true without revealing any information about or any of the details about what it is. So in cryptocurrency land, I can prove that I have a sufficient balance to give a certain amount to another counterparty without sharing with the network who those counterparties are or how much was transacted. I know that sounds counterintuitive and insane. The math works. And so the notion of what we call trusted or cryptographic proofs of the legitimacy or validity of a transaction are feasible. And so you report that proof to the blockchain. You don't report the details of the transaction to the blockchain. Drawback here is that these things are really bleeding edge and very computationally expensive. We did some experiments at a hackathon on the Ethereum blockchain and estimated that our transaction fees, our gas cost in Ethereum for running one of these kinds of transactions was about $650 to transact a single. Right? And so all that computational power that you need to generate those kinds of proofs is really not ready for prime time yet, nor is it very fast at all. There are innumerable other kinds of approaches. Maybe we can just encrypt the data and then put it on the blockchain. Of course, then we have to have a provision for exchanging keys, and then you got to decrypt the data. And if it's encrypted data on the blockchain, really smart contracts can't do anything to them because you can't really apply applications to encrypted data until another bleeding edge form of cryptography comes along, something called homomorphic encryption. But there's tons of different approaches. I like the simple ones the best. So something like, if you don't want to share the information, don't share the information. It sounds simple. Don't put it on the ledger, or have a ledger that doesn't share it with parties who fundamentally shouldn't see it. There's a whole area of game theory that I've recently been researching about utility cost for maintaining privacy. The effort that parties will go to hide information on an open or transparent network actually has a very negative cost on the overall efficiency of the system. And so privacy guarantees are not just a nice to have, they actually have a very tangible impact on the ability for value creation of these systems that we can actually measure and quantify. And so this is a really important area in enterprise blockchain, and it's necessary from a wide variety of regulatory and privacy regulations, not least of which in my industry is HIPAA, but things like GDPR, PII sharing for financial information, AML, KYC kinds of functions as well. And so privacy is a core demand for enterprise to utilize this technology. And so the different privacy mechanisms that come with some of these protocols is really, really important, which is why I think the return of the database is a really interesting model, because I know who has the data. I can have a service level agreement with them. I can have a master services agreement with them. I can have a business associates agreement with them. And I know who to sue if they breach. So that businesses understand. They don't understand a zero knowledge proof. I don't think any of us really do. They understand that other legal agreement. And so the simpler is going to usually work, at least in the near term, for a lot of these kinds of solutions.
Any last questions?
Yeah.
So you talked about like privacy of older blockchain where it's all like they have legal systems to enforce.
Mm-hmm.
Has there been any cases gone through where someone has presented evidence of this ledger to prove that someone?
That's a great question. I don't know. That brings to mind all kinds of sayings, mostly from the Ethereum movement, that code is law, right? Smart contract is law. And there are even some states, Tennessee included, which have said, yeah, smart contracts can be legally enforceable. In my opinion, I'm not a lawyer. I'll say that up front. Most of that is redundant law, because most legal systems in the states already recognize digital signatures as legal and enforceable. And so we really didn't need this notion that smart contracts are actual contracts. But I'm not aware of any court cases where a breach of contract term was brought and the evidence was some sort of ledger record underneath the smart contract. There's all kinds of interesting functions. Court has got a really interesting one. You can actually attach legal documents to the transaction, right? And say, hey, this transaction is governed by this legal document. And if you accept the transaction, you're fundamentally agreeing to that. There's your signature on it. And so it's exactly provisioned. It's not about trustlessness. It's about auditability and enforceability. If you're gonna, you can lie to the ledger. You can lie to the ledger all day long. But if you lie to the ledger, I'm gonna have a record of it with a nice timestamp on it and a legal document attached when you lie. That's usually the best place to start. But that's a great question.
All right.
All right, John.
Thank you, Corey.
Thank you all.
Thanks for everybody coming out. Special thanks to the team at Hash, especially Giles, for helping coordinate Nashville Blockchain Meetup. Thank you to LBNC. Thanks to Frost Brown Todd. Thanks to BTC Media, our sponsors. Thanks to WeWork. We have sponsorship openings coming up soon. So if you want to, any companies that want to sponsor the meetup, talk to Giles. Upcoming conversations this year include the emerging consortia in healthcare. We're doing some research right now on the consortia that are coming out. There are 2 consortia, big kind of healthcare consortia announced in 2018, and there have been 5 so far this year in 2019. And so we're starting to do some research and some newsletters that are focused on what we're learning from these enterprise consortia that are emerging, some of the design patterns in those consortia, some of the protocols being used by those consortia, et cetera. And there's, I think, a lot of indicators that we can look at in terms of what we can expect in the second half of this year. We're involved in 2 of those at Hashed, and we see we're planning on being involved in a couple more. So that's a big trend that we want to share with you guys. We also have some work in the opioid space that we're planning on focusing on later this year, and we plan on doing a meetup around that. We're going to have Good Shepherd and the Remedy chain folks come up from Memphis to talk about their project around track and trace for pharma. I'm not sure what else, but those are some of the topics coming up kind of second half of the year. So we hope that, thank you for coming, and we hope you'll come back again. And thanks to all who joined us on the live stream. And until next time, we appreciate you guys being a part of the Nashville Blockchain Meetup. Thank you.